Welcome back, my friends, to the show that never ends. We are live here on Audioholics. It is a Friday night, June 28th, 11 p.m., our usual time where we try to do these live broadcasts. We've got Matthew. Sorry about that. We've got Matthew Pose here. How you doing, Matthew?
Hey, Gene, I'm doing good, and this is an exciting topic.
Yeah, so today we're going to talk about active versus passive speakers. This is something I wanted to cover for a while. It was kind of on the back burner. We had it on our to-do list before. But then I saw this video pop up a week or two ago by this pretentious reviewer, what's his name, Steve Gutenberg, talking about how active speakers, you should watch out before you buy them because there's so many things wrong with active speakers. And I tried watching that video, and it just kind of made my stomach turn a little bit with all the misinformation that I found in that video. So I thought it'd be a good time to do a video on active versus passive speakers, put some science into it and not so much emotion and so many blanketed statements. So I think what I'd like to start out with, Matt, is we should define to the audience what an active speaker is and what a passive speaker is. Let me just give you guys a dirty rundown, and then Matt can go into this in more detail. So you've got two different kinds of speakers. You got a passive speaker, which is what most speakers you buy, box speakers you buy in the store that you plug into your AVR or your amplifier. And all that is it's a speaker with drivers in it and a passive crossover, which uses elements like RLCs, resistors, capacitors, inductors. So it's an analog network. There's no active components in that speaker usually. And that's a passive speaker. Then you've got active speakers, and there's different levels of active speakers. You've got the really sophisticated active speakers have built-in DSP processing. They have fully digital crossovers done in the digital domain through a DSP or through an active op-amp kind of design. And then they have built-in amplification. So the active speaker itself is usually a closed loop system. So the amplifier is built in, the DSP is built in if it does room correction or if it does any type of other correction to match the speakers better with the amplifiers. And there's usually no analog crossovers. Now there's always exceptions. When the cheaper active speakers, they still can employ analog crossovers and still put an amplifier in them. Some of them are wireless, that way you could do streaming to them. So I think that's a good overview, very basic overview comparison of an active versus a passive speaker. Matt, what I'd like to do is I'd like for you to talk a little bit about the advantages. Let's start out with the advantages of a passive speaker, and then we'll talk about the advantages of active speakers and the pros and cons of both.
Sure. Well, Gene, let me just start by saying that I think at this rate I'm going to have no friends left in this industry. But we should jump in and talk about the pros, because active speakers actually have... You wanted to start with active speakers? Is that what you said?
Actually, let's start with passive speakers.
Passive,
what are the pros of passive speakers?
All right, I mixed myself up. So passive speakers, right. So, I mean, one of the pros, I think, is the concept of parity. So I just want to start with that. And that's the notion that two things are equal. So passive crossovers work. I mean, that's one of the things we have to accept. So just to kind of briefly reiterate what you said in simple terms, an active speaker puts the crossover before the amplifier. A passive speaker puts the crossover after the amplifier. And so the type of components that are used and the way that they're put together has to be different. The passive crossover has to be significantly larger and capable of handling quite a bit more power through it. But at the end of the day, it is completely feasible to create a speaker using a passive filter that is technically excellent, sounds good, measures very well. And they're simple to design in some ways. They're the oldest design of speakers. You know, the use of active crossovers is something that required technology that didn't exist until, I mean, I guess in some ways probably the 50s and 60s, but it really didn't come into vogue, I think, until probably the 70s and 80s. And most recently, now with digital technology, has really taken off and become very commonplace. So passive speakers were easier to design in many cases. They're easier to implement. And one of the big benefits of them is that you can, bring your own amplifier, bring your own beer. In this case, you bring your own amplifier of choice, of style and sound that you like. And the amplifier can be quite large in these regards too. So if you want to have a 200 watt per channel amplifier, 500 watt, 1000 watt, whatever, you can certainly build speakers and crossovers that can handle that. And that's not all that uncommon. So I think for many people, it's just a simpler approach that works pretty well and allows you to use the components you want to use the way you want to use them.
Yeah, backing up for a second on a passive speaker, when you're talking about these components, the RLCs,
Mhm.
it's really the component that takes a brunt of the power is really when you put an inductor on those woofers. You know, that's where you're getting, especially at bass frequencies. That's where I like, for example, in my speakers, my Status ATs, the RBH speakers, $50,000 pair of massive towers, the inductor on the bass section looks like a transformer. I mean, it is literally like this big, super expensive component to use, very high, a very low gauge coil, so it handles a ton of power with very low loss, very low DCR. So to further expand on your point about you can make an excellent passive speaker, I would also argue to say that if you want to do a really good passive speaker with very little losses to give you the linearity that you can get from the very best active speakers, it costs money. It costs money to use good components. It costs money to use good drive technology, to use especially the capacitors that you use on the high frequency sections. You know, when people cut corners, they put electrolytic caps. And then, as you know, electrolytics are not very linear at high frequencies. Sometimes you have to bypass them with some poly caps in parallel to lower the ESR. So there's a lot of tricks you have to do to a passive network to get it right. The other thing I like to talk about passive networks is a lot of companies, they kind of mess them up. I mean, we've seen this in some of our recent reviews on some very popular speakers, on a particular tower speaker, a British tower speaker that had a huge dip at 2 kilohertz because they were trying to cross over a 6-inch woofer too high in frequency. And maybe the tweeter didn't have enough output capability at lower frequencies. But the point of the matter is, when you're designing a passive speaker that has an unknown output impedance coming from the drive section, you're not designing for a known termination and a known load, it gets tricky. And if you're not doing things right and you're not looking at the system correctly, you can make more, I think you can make more design mistakes with a passive network than you can with an active network. Wondering what your thoughts on that are.
Yeah, I guess I might play devil's advocate and say that you can mess up either crossover pretty equally.
Yeah.
And, you know, I think if this was 20, 30 years ago, you had to have a pretty solid understanding in mathematics and electrical engineering to be able to design a good crossover. And to be honest, 20, 30 years ago, our understanding of crossovers wasn't what it is today. And that's not that long ago. 50, 60 years ago, our understanding of crossovers sucked. So, you know, one of the things that's changed today is that you can use computer programs with advanced mathematical models to design these, whether they're active or passive. And as long as you know what you're doing, either should be good. If you don't know what you're doing, either is going to be bad.
Yeah, I guess in some cases when you can get a really expensive speaker that measures badly, as Dr. Floyd Toole would say, that those cases are ecological disasters because you're wasting materials, you know, good materials with bad execution. So I guess that, like you said, that happens in any case. But I would argue that if you really want a no compromise system, I guess it can be said for both, but I've noticed that when you cut corners in the passive components, it really does make a difference in passive loudspeakers and performance.
Yeah. Well, one of the issues with passive crossovers, as we talked about, is the crossover itself is a lossy device. It basically dissipates some of that power as heat. They're not totally linear. The parts that they use don't react the way that you would want them to. They're not ideal parts. And so they affect the response negatively. They create distortion, meaning as you get louder, they start to do things like add harmonics. And so,
You're talking about inductor saturation, like if you use an iron core as opposed to an air core, right?
yeah, that would be one example. The resistors themselves can have some issues depending on, you know, whether they're non-inductive or not and how good they are. You know, something can be considered non-inductive and not actually truly be. They wear out from heat. You know, they are taking a lot of abuse. And so modern passive crossovers do tend to be pretty reliable, but parts quality still is an issue. The old ones tended not to be. I used to rebuild speakers from the 70s quite a bit when I was a kid, because, you know, within 20 years, those things were dying. Today, I think a modern speaker should last that long. I don't know. That might be naive to think that. But the bigger point is that those parts need to be high quality. They are very expensive, as you said, to get good high quality parts, and they're imperfect. I mean, one of the things about digital crossovers that becomes an advantage to those is that they're capable of being perfect from the standpoint of how they behave. You set a crossover at Linkwitz-Riley fourth order, 1000 hertz, and it will be exactly that perfectly. You build one using passive components, and you can get very close, but it's never going to be perfect.
And I don't want to dive off topic too far, but I do notice there are some companies that say, hey, we use the least amount of crossover components possible in our loudspeaker design. Like we'll use first order crossovers instead of fourth order or Linkwitz-Riley crossovers. A lot of that is snake oil, because when you make things too simple and you do only first order crossovers in a loudspeaker, now you're at the mercy of the driver taking the brunt of the out of band noise or the out of band signal that it really shouldn't be producing, which makes you produce those resonances more because they're not being controlled by the network. It also can make you reduce dynamic range of the speaker, because now you've decreased the power handling of the speaker by not putting the right network on it. So I would say when you look at loudspeaker manufacturer specs and they say, hey, we use the simplest crossovers possible. I mean, I've seen years ago, there were some speakers from Teal that used to say they used first order crossovers, and you looked at the crossover network and this thing was really complex. There's no way it was a first order filter. And in most cases, first order filters are not the better solution for crossover designs. You know, the higher order sloped crossovers have advantages for controlling breakup and also for better driver integration, even phase coherency and better power handling.
Right. The Teal speakers you're talking about, actually, they really did use a first order crossover, but what they did was they used a very complex response shaping set of filters in there in addition to the first order crossover to help make sure that the response itself was smooth. And that's really a separate issue, but and they did that for actually the same reason that the British company we're talking about does it. It allows you to have a speaker that can pass a square wave. I mean, that's the simplest way of describing why they're choosing to do that, is they're trying to make a speaker capable of doing that. And anything above a first order can't. And so there are people who believe that that is important. Now, you mentioned Floyd Toole. My understanding of his work, though, is that prioritizing the ability to reproduce a square wave through a speaker is prioritizing the wrong thing. While it may matter to some extent, there are other aspects of speaker sound that are significantly more important, one of them being the amplitude response. And so you compromise that amplitude response quite a bit when you try to get away with a first order filter. Even when you do a lot of response shaping, basically you create too many limitations. And then the other one being, as you mentioned, first order doesn't do a good enough job, in the case of a tweeter, for instance, protecting that tweeter against the out of band noise, the low frequencies that it's trying to produce that it shouldn't be, and it starts to produce distortion. So like normally in a speaker, we would say nonlinear distortion is not really a major concern. Well, when you start designing speakers like that, you either need to design a really robust tweeter. That's what that British company does. And so they have a really, really expensive tweeter in that speaker. Or you end up having to accept that you're going to have higher levels of nonlinear distortion to the point that it's audible and problematic.
Yeah, I think you hit the nail on the head there, that sometimes with these loudspeakers, a company can go too far down one avenue of pursuit, when in reality the most important aspects can often be overlooked, like amplitude response and distortion, off-axis response, that kind of stuff. I think it's important to note that either active or passive can be equally good or equally bad in that aspect if the design goals aren't met clearly.
Yeah, and actually that gets us into the concept of advantages of active speakers, if you want to jump into that.
Well, one more thing I'll give to the passive. Two more advantages I give to passive speakers: the fact that you can use whatever audiophile amplifier you want, and I think that's where Steve Gutenberg and the stereophile crowd really kind of are against active speakers, and they like passive speakers because they like to mix and match. They like to mix their amplifiers with a certain speaker, and they believe there's some synergy between them. And sometimes there's some validity to that. There can be synergy between components. And people do like having giant amplifiers on display. They put it on the floor, they put it on a little stand, whatever. They like to have the big linear AB amplifiers with the power meters. You can't do that in most cases with an active speaker. And then you also get more cabinet space inside of a passive speaker usually than an active if you're sticking the amplifiers inside the active speaker. But of course, the really high-powered active speakers don't have any electronics in them. It's usually done outboard, with a DSP and an amplifier, maybe done in one box or maybe done in two boxes. So I guess the biggest advantage to passive speakers there is, again, you can mix and match your own components. You're not a slave to a closed loop system. You can you have full control over what you want to use there.
Yeah, you're absolutely right. In fact, speaking of Harman, JBL introduced a very well-respected, very good-sounding studio monitor called the M2, and that uses external amplification, but it's a fully active speaker. While there is a crossover component on the tweeter, it's not actually part of the overall crossover design. It serves a different purpose, and so that's a good example of a high-end speaker that can be used in home and is quite a bit that uses external amplification. Now, some people will note that that was designed to use a particular crown amplifier that not everybody likes the sound of, which I think is what you're getting at. And, as somebody who doesn't buy into a lot of the amp sound different kind of stuff that's out there, I will say in the case of that amp, it happens to be a very noisy Class D amplifier.
Yeah.
So there's reason to not like that, even though it's a high-end amp. But one of the nice things that's come out is people have figured out what the crossovers are in that system and introduced it so that you can use external digital crossovers with your own amplification. And that's another thing with active speakers. You don't have to use a built-in amplifier, nor do you have to necessarily use a specific amplifier. You do have to use specific crossovers because the person who designs the speaker needs to design it that way. But it is perfectly feasible that somebody, one of the issues here is that active speakers aren't very common in audiophile world, if you will. Like, it's not a big part of our world. It's more a part of pro audio.
Not yet, at least, because I do see a trend coming now where you're starting to see high performance companies. You see Dyne Audio's doing it. Even Golden Ear has active speakers. RBH Sound is doing it. I'm seeing, and CAF, for example, I'm seeing more and more consumer audio, serious audio products are going active now in wireless.
Sure. But for sure with the wireless stuff, with the non-wireless, I guess the highest end audio stuff that would be a replacement for some of the gear like you or I would buy, I think it remains pretty uncommon. My point, though, was that I think that if it was more common in our field, we actually would see probably a lot more options that would allow for external amplification. But because it's either being used to create kind of like high-end lifestyle products or is basically pro audio gear made for the home, you tend to see the amplification built in and essentially being not just closed loop, but fully enclosed as well. So the point being, some of those things that, like, for instance, Steve doesn't like, they don't have to be true. They just happen to be true right now.
In some cases, yeah.
Yeah.
So why don't we talk about now some of the advantages of the active speaker, having the full control of manipulating your crossover response in the digital domain as opposed to trying to use elements, lossy elements.
Well, so one of the things to kind of start with is that a crossover itself is a filter, and we think of that filter typically as being what the term crossover means, meaning that it simply is providing a low pass filter on the mid bass driver, which means that the high frequencies are being rolled off, and a high pass filter on the high frequency driver, the tweeter, which means the low frequencies are being rolled off. And you do it in such a way that the two can blend together and create a flat response. So that the thing that is missed there, though, is that assumes that the speaker drivers themselves have a perfectly flat response, and they don't. So all crossovers are actually a whole bunch of filters. It's not just a crossover on the woofer, crossover, for the tweeter, I should say, a low pass filter on the woofer, a high pass filter on the tweeter, creating a crossover. There's actually EQ as well. And on good high-end speakers, there's often quite a bit of EQ going on, a lot of response shaping used to create a nice flat response. So the problem is getting all those parts matched is very difficult. And what you end up having to do is buying a large quantity of parts, a whole bunch of inductors in the value that you need, a whole bunch of resistors, and a whole bunch of capacitors. You then not only have to design the crossover, you have to test all those parts and match them in very, very tight tolerances in order to ensure that when you put together those crossovers, every one of them measures exactly the way it's supposed to, so that those EQ points are exactly where they're supposed to be. Otherwise, the natural tolerance on those large parts, and as you know, as somebody who has a background in this, very large things like inductors and resistors tend to have wider tolerances on them than something like a very small resistor, like a surface mount part would be. So there's no such thing as a 0.01% tolerance inductor that can handle 500 watts.
Yeah,
They
you're
tend to
looking
be
probably more like 5-10% in those cases.
Exactly. And when you're trying to create, it's actually, the crossovers often look like, just as an example, like a PEQ filter, a parametric EQ. So when you're trying to create a parametric EQ, you've got a center frequency. Well, if those values are off, the center frequency can move around. And in the case of a speaker, that position of that center frequency is pretty important to the flat response. So one of the advantages of active speakers is that that's not a concern at all, especially when you're dealing with digital. When you set that crossover, it's exactly what you want it to be. Those equalization filters that are applied are exactly where they're supposed to be. The Q, the bandwidth, essentially the shape and width of that filter is exactly what it's supposed to be. And so you can design a speaker whose amplitude response is significantly more precise. The other thing is that there's typically about 2 to 3 parts per EQ filter, and anywhere from technically as low as 1, but in most good speakers, 2 to as many as like 8 to 10 parts to create a high order low pass or high pass filter. So you add all those elements together, and then let's just say you need 3 or 4 EQ bands. And so you may be looking at another, for instance, like 12 parts. You could look at a crossover that has something like 30, 40 total elements in it. So that's huge. It's not just expensive. You're talking about something that's physically very large. With a digital crossover, you can easily have, they're called biquads. That refers to the particular filters there. You could easily have 15 biquads for the woofer and 15 biquads for the tweeter, in something that could fit easily, probably on your thumbnail, to be honest. I mean, the digital stuff can be really tiny. So an amplifier that easily fits in your hand can have all the parts that normally would be, taking up a spot that's probably like a full square foot.
Yeah,
So
and let's not forget, when you're not using passive crossovers, those big inductors. I mean, when you use those, you have to be careful with layout, because if you put coils too close together and they're not orthogonally located, you can get crosstalk between them or coupling, and that's usually something you don't want, and that changes the response as well. So that's not something you have to worry about when you do an active.
You're right. And actually, when I designed and built, I shouldn't say designed, they were designed by Earl Geddes, but when I built my speakers and I did modifications to the crossover, one of the problems I had was that the crossover was complex enough that I had too many inductors to be able to lay them all out orthogonally, as you mentioned. There's just too many of them. So I had to take advantage of 3D space as much as I could, but the reality is some of them just had to be pushed as far apart as possible because they were going to otherwise interact with each other. And with an active speaker, it's just like you said, it's not a concern. So anyway, the point is the filters are more precise. You typically have more filters at your disposal, which allows you to have a flatter response. And then there's another neat thing, but I don't want to make too big a deal out of this. It's one of those that, as like a tech person, I think this is cool, but I also recognize that from a sound quality standpoint, probably isn't as cool as it sounds. It can be cool, but it's got issues. And that's that with analog filters, what you're basically recreating are what are called IIR filters, so infinite impulse response filters. And all analog filters and most of the standard active filters that you see even digitally are of the IIR type. And to be honest, they work fine. They have their problems, but overall you can make a very good speaker that way. But there's another kind of filter called a finite impulse response, or FIR filter, that actually can do some pretty cool things. Basically what it can do is it can work on both the time aspect and the frequency amplitude aspect separately. And by allowing you to do that, it allows you to create a speaker that can have basically a perfect amplitude response and a perfect time response. It can pass a square wave. And this is very cool because you can make a speaker that has all the advantages that a company like B&W or Teal was going after, but with an absolutely perfect response. The problem is doing that well is very resource intensive on the DSP chip, and it can introduce things like ringing, and it can be audible if not handled correctly. So it becomes like anything else, a balancing act.
You're talking about like if you use a very high order crossover, let's say a high pass on a subwoofer driver, for example. It's the out of band that would actually, right at the out of band, that would start ringing with an impulse, and you can actually physically hear that. Is that what you're talking about?
that would be an example. You could use this on a tweeter too, and it would do the exact same thing on it. So it's not that FIR is bad. It's great. It's just that it can be problematic, and you have to know how to use it and design with them. A lot of people who have used them in the past did not know what they were doing and introduced a significant amount of ringing as a result of that. And it creates an audibly inferior speaker at that point. Like whatever advantage you thought you were getting out of it, you basically lost by adding in that problem.
Yeah. Well, one thing I would say that active speakers have a huge advantage on is when you're in car audio. I know when I visited the folks at JL Audio, and I'm going to have a video on this in a week or two, and they were tuning my BMW system that I put in using their TWK88 DSP. They were wishing that I didn't put passive crossovers with the Morel speakers I used. They wanted to use the active filters in their unit. And at the time when I installed everything, I didn't really think about doing that, and it would have required extra amplification, because then I would have had to have had separate amplifiers for the tweeters, separate amplifiers for the mids, and separate amplifiers for the underseat woofers. But they were talking about how just amazing it is when you can use all pass filters to do all the shaping and to get the drivers perfectly integrated. I guess that's a huge advantage in car audio when you don't have the space, first of all, to put these complex crossovers into the door panels. I know the crossovers for the Morels were actually quite large. It was like a home audio crossover. The thing was this big. And when I pulled the door panel off, we had to use zip ties and really get that into the door panel. And then you also have to be worried about, putting those coils too close to any magnetics that are in the door that could, the motorized door, the window up and down and stuff. You don't want to have any interference there. So active is a huge advantage in car audio. You could just do so much with the DSP, minimize, like you said, all of the components by going in the digital domain. Maybe you want to talk a little bit about that as well.
Talk about the use of the digital for the crossover, you're saying?
Yeah, like or the all pass filter, where my understanding with the all pass filters, you could actually do shaping without messing with the amplitude response at all.
Yeah. So an all pass filter is basically a way of changing the timing of something. It's a phase filter, if you will.
Right.
And it won't affect the frequency, the amplitude response of it. Let's say in a reflection free zone, it would not do that. Once you put it inside of a car or in a room, it will actually, and with other drivers, that's another important part. Is once it's integrating with other drivers, then because it's affecting the phase relationship between the other drivers and interacting with reflections off of the cabinet or the room or the car or whatever, an all pass filter can shape the response itself as well as that. But yes, basically what you're getting at was something I was also trying to get at a little bit. So there's an all pass filter that's implemented using an IIR filter, is one that allows you to adjust the phase without having a major impact on the frequency response. And that can be used to integrate things so that your tweeter and your woofer are essentially arriving at your ear at the same time. And that's something that you can technically do with a passive filter. It's extremely difficult to do. In fact, the only way I know, I'll admit I'm not the smartest person in the world when it comes to this stuff, but the only way I know to do that is with something called a number solver. It's basically an algorithm that runs iteratively through the different values until it comes up with a value combination that gives you the time delay that you want. I've seen them used in commercial speakers, I think never, but I've seen them designed before by some DIY guys who I think were just showing off, to be honest. They're very complex. On the other hand, in the digital domain with an active speaker, they're extremely easy to implement, and it's one of the ways you can create a much more coherent speaker. They're great for car audio, as you said, because the speakers are simply not on the same plane, and that's a very common problem with them. And then there's a very advanced way of doing this, which is using FIR filters, and that basically allows you to take it to a whole nother level. But as I said, FIR filters are something that need to be used cautiously.
Well, yeah, and then the other thing you consider too when you do active designs is it takes a lot of load off of the amplifier, because now you could bandwidth limit those drivers before you even do any amplification at all. You do it at the line level, and then you could also have better impedance matching between the amplifier and the loudspeaker. And some of the I guess cost-effective Class D amplifiers, the biggest downfall on some of those amplifiers is they change their response drastically based on load impedance. Well, that becomes less of a problem once you go active, and you could really match that crossover network, the active crossover network, to the drivers, to the amplifier as a total system. You can get much better efficiency out of that and have that amplifier work better than it would if it had an analog crossover attached to the drivers.
Exactly. So, but there's a caveat I want to say here. There's a lot of misinformation out there about the advantages of active speakers that talk about things like distortion reduction. And a lot of that is overblowing an issue that is actually pretty minute. However, there are some serious advantages to this approach. So when you put an active crossover on the amplifier, one of the big things you can do is use steeper slopes, for instance, than you typically would be able to get away with as cheaply and easily as with passive. And that actually allows the amplifier to have to deliver less power because it's not trying to produce power in that out of band area. Now, another advantage is that, as you mentioned, you can start to match the amplifier to the tweeter. Now, with Class AB amplifiers, while there are exceptions, a lot of them tend to be pretty linear. They tend to be load like they don't care about the load.
Yeah, load agnostic, basically.
There we go. Yeah, load agnostic. With Class D, that's not true. It has to do with the output filter. So with cheap Class D amplifiers, and there's some really cheap ones they're called filterless. They actually rely on the natural inductance of the driver itself to act as its filter. The response changes dramatically with load. And typically what happens is the high frequencies roll off more at lower impedances. Well, if you're building an active speaker, which is what we call a closed loop system, in other words, you know everything. You know the amplifier's characteristics, you know the speaker driver's characteristics, you know everything that's going on there, then you don't need to worry about these issues. You just pick a tweeter that you know, for instance, with that amplifier will have the response that you want. And any change in response that you don't want, you can actually tune into the EQ. So for instance, if it is rolling the highs off, you can put a filter on that would counteract that. So the other thing you can do is you can actually tune that output filter on the amplifier to work for that bandwidth that it needs to operate in. So you can build, let's say you're making a three-way speaker. You've got a woofer, a mid-range, and a tweeter. You could actually build three separate amplifiers whose response is optimized specifically for each of those bandwidths that it's going to be operating within. So in the bass range on that woofer, you could actually use a pretty cheap standard Class D amplifier, but one that you know, for instance, has good current delivery and is capable of producing a lot of power. You wouldn't need to worry about its frequency response because at the range that it's going to operate in, it's not going to be a problem. In the mid-range, you still don't need to worry about the high frequencies anymore, but you'd probably want to be optimizing it more for low distortion and low noise. In the high frequencies, you can get away with a lower power amplifier because the tweeter simply doesn't need as much power. But you will need to make sure that it's the lowest noise, lowest distortion, most linear response to be good, right? So you can just design those amplifiers and tune those output filters on the amplifiers to be optimal for that. And that allows you to make a speaker that has at the high end, like a upper end system, the best possible performance, but at the low end, it allows you to still have a very good performing system for less money.
And that's why you see some of these active speakers, they put more power on the bass driver and less power on the tweeter. You just use less power for high frequencies. Obviously, the most power you use is typically on your bass drivers. So it makes sense. You don't have to use this massive amplifier anymore. You could do what's called active biamping. And like you were saying, Matt, you could perfectly match the tweeter or the driver to the amplifier based on its application. The other thing I would say that is an advantage to active speakers is when you want to actually bring that speaker into a room and tune it for that room. Now, I know we always talk about making a speaker flat anechoically is the best approach, and you want to know the off-axis response because when you know what to expect, you know how to match a room and get all the early reflections to sum properly and everything else. But in real rooms, you're always going to be doing some type of tweaking, whether you're using auto EQ or you're doing manual PEQ, whatever. The point of the matter is it's a lot easier to customize the response of that speaker in the room when it's an active speaker as opposed to a passive speaker, because now you have that whole closed loop system. The really smart systems will have the ability to go and change some of the filter responses. They may even implement something like DRAC or REW, REQ into the program. I'm seeing some of that happening with next generation speakers now, where you can actually have the final closed loop response, but then go in and tune it to whatever your room is. I think that's a huge advantage that you typically don't get with passive speakers.
Yeah, that's really what Legacy Audio has been moving towards. Bill has been designing speakers now around his wavelet processor, which allows him to do both active crossovers in his speakers. And I believe even his highest end are still a blend of passive and active. I could be wrong about that, but that processor itself is capable of making his speakers active. And what he does is he then uses its ability to do some room response shaping as well. And he's got an interesting belief. I'm not going to say I agree or disagree, because it's one of those things that I'd want to look into more. But his argument is that room modes, which are typically what we're most worried about when we're tweaking the bass, are actually not a major concern if you address a different kind of bass interference. And it's what I call SBIR, or speaker boundary interference response. So what he does is he actually has the microphone near the speaker.
Yes.
It measures the direct response from the speaker. It also measures the reflection of the response from the speaker, that once it hits a wall nearby, like behind the speaker, and that reflection comes back past the speaker. So because it's time delayed, the measurement can tell the difference between the direct response, because the mic was only, let's say, a foot from the speaker, and the reflected response, which probably was 6 feet or 10 feet or whatever from the speaker in terms of total distance traveled. And then it can counteract the effect of that reflection. And what he says is, once you actually address that, and that actually is one of the major things that corrupts the response of a speaker outside of room modes, he finds that the sound, at least in the room, is very smooth, that tends to deal with the most egregious problems. And that is definitely something you can only do actively.
Yeah, and I got a chance to actually fly out to Legacy. I think it was like a year, maybe 2 years ago. And I got to hear the Valor, which was that exact system you're talking about with the wavelet processor, all active amplification. It was using the next generation ICE modules, the ones that are actually better at handling high frequencies than the first generation ones we saw. And I have to tell you, it was an awesome sounding system. It really blew my mind when he turned the room correction on and off. At first, I was like, this is kind of weird how he's measuring it with the microphone only a few feet away from the speaker. But then he started talking about, the cardiac response of the bass and all this other stuff. And I sat and listened. I was like, you know what? This sounds like a really good, well-integrated system. And the imaging was excellent on it. And this was just an ordinary room. He didn't believe in turning the room into an anechoic chamber. He didn't put bass traps all over the room. And not to veer off topic, but if you design your system well and you get the resonances controlled using multi-sub, you don't need to fill a room with bass traps. You just don't. I mean, you allow the speaker to be an active bass trap for sound reproduction. So there's definitely some advantages there. And then that DSP control, man, just to be able to tune that system in is something it's harder to do with a passive system.
Absolutely. Yeah. And I think that approach has a lot of merit to it as well. I think that the auto EQ approach that a lot of people take advantage of, which I get, it's available to most of us, that the type of system Bill uses is not. But in my own work setting up systems, what I found often is that those SBIR effects do tend to be the strongest problem. And it's important to address those first. In a lot of the work that I do, it's either done through EQ in a similar manner to what he does. And I gave a presentation, in fact, recently on the use of wavelets without realizing that he was doing the same thing in his system. Or the other thing I do is actually just essentially fix the SBIR effect in a passive way. So the passive way to fix SBIR effects, other than putting treatments in a room, which is actually pretty difficult to do, is to move the speaker until it's not a problem anymore. And so, you can see the advantages of being able to do that digitally in a processor instead of having to move speakers all over the room until you find the magic place where it's not a problem. And it's not magic, I know, it's science and you can figure it out, but it doesn't change the fact that it's a pain in the butt to figure out.
Yeah, there's no doubt. I mean, and if you don't have an active system, obviously, like I don't currently have an active system, my speaker's passive. I use some good EQ. I have the mini DSP that I use to manage the multi-sub in my system, which is all PEQ filter based. If you don't have something like that, because that does require you to pull measurements and trial and error kind of approach, there are some good room correction systems that limit your correction down to the bass frequencies, like Anthem's Arc, or even Odyssey can do that. D-Rack is another one. So room correction is a great tool in a passive system to try to get you where you're going, kind of like what we're doing with these active systems now. But there's more than one way to skin a cat, obviously, and not one is superior to another. But we don't deal with absolutes. There's pros and cons to every type of system. But I will tell you this much: active systems are really dominant in I guess close field monitoring systems. Whether you're doing like mixing studios and stuff, they've been using active speakers for a very long time, and there's a lot of advantages space-wise because they don't have to put all these extra components in. So there's probably other reasons why they've adopted active systems, way before consumer audio has. I mean, what do you think about that when you're dealing with mixing studios and stuff?
Yeah, I mean, I think the reality is they did it because it's better. And we've already talked about a lot of the technical reasons why it's better. I mean, another reason is that they have limited rack space. So having an active speaker allows them to integrate everything into one box, makes it a little bit easier. But I don't think that's the only reason. I mean, you can make pretty small amplifiers these days. I really think that it was because it was a superior approach. And so when it comes down to being able to produce a speaker that has got the best, most linear response possible for the least amount of money, which is something that even in studios matters. You're talking about a $10,000 speaker. The reality is that there's cost decisions that need to be made there. You could always spend more to make a better speaker. And with active, you can simply do better things cheaper and easier than you can with passive systems. So while my belief is that you can make an equally good passive system to an active system, at any price point, it'll always be that much better in the active system for that amount of money because less compromises are being made on things like buying really big, expensive inductors. And I think in the pro audio world, what they were recognizing was they needed systems that could reproduce a known output level. So they needed to get a certain loudness without distortion. And they needed to know that. The people doing the mixing needed to be able to rely on these to be loud enough for their mixing. They needed to have a really good frequency response, and they needed to know that it was good, and they needed to not worry about the interaction with the amplifier and everything else. And I think that the other part of it was they needed some flexibility. So one of the things you notice about a lot of these pro studio monitors is that the older ones, or the ones that are based on analog systems, tend to be loaded up with filter switches on the back that adjust the bass and the treble and you name it. And the new ones tend to use digital systems with all the same filter adjustments. And I think that was because they recognize that some people are sticking them against a wall. Some people are sticking them inside niches in the wall. Some people are sticking them up on stands out in the room, and all those different locations, and treated differently. I mean, a lot of these rooms are built so that they've got, diffusers everywhere, or they have absorption everywhere. They're referred to as environment free rooms, basically, or non-environment rooms, where a lot of those reflections are being either redirected or fully eliminated. And so you needed to be able to adjust the response of the speaker pretty dramatically, pretty easily. And so I think that active was just the better way to achieve all of those goals that they had.
Yeah. What I think is amazing over the last 5 or 6 years is how inexpensive good active designs have become. I mean, you look at JBL, for example, their 3 series. It's just, I think it's the L305 or 306. You can literally get those for $300-400 a pair, sometimes less. Sometimes you can get them on, Black Friday deals for $200 a pair. The kind of performance you get out of a speaker like that, it boggles the mind of how good they are and how much sound you can get, as opposed to going and just getting a sound bar in a house, in a TV, which is why I always tell people, if you're going to spend $400 or $500 on a sound bar, just get an active speaker system. I mean, you've got the JBLs are great. There's another company that I've been reviewing that I'm really impressed with called Edifier. And all their stuff is done with active DSP, Class D amplification, good drive components. They're not using cheap parts. We're talking about some really good parts. I'm looking at a system called the AirPulse A200 from Edifier. They're about $800 a pair. They use a really nice horn-loaded ribbon tweeter and a really high-quality aluminum cone driver, and good amplification, good DSP. I think it's like 96 kilohertz sampling rate. So, I mean, active speakers for consumer audio have come so full circle in the last 5 years that you simply can't ignore them.
Yeah, and I think that's actually in many ways a mixture of the modern improvements in digital technology and commoditization of these components. So one of the things that used to be a problem, and it's one of the reasons why a lot of people don't like active speakers, is that if it is using an active digital design like we're talking about here, then it has to convert the incoming signal, potentially at least, from analog out of your processor, your receiver, whatever, to digital, process that signal, and it has to do so in a proper way so that it doesn't alter it in any unwanted ways, and then convert it back to analog again before going into the amplifier. And in the old days, especially before we had the modern 24 or 32-bit and then 192 on up kilohertz converters, and many of those converters, even if they were rated for 24-bit 192, could not achieve that technical performance. The problem you had was that the analog to digital converter was introducing a lot of noise and was doing an imperfect job. It was limiting to the dynamic range. It was adding distortion. It would go into the DSP itself, where there sometimes were problems there. And so you got all these advantages from the filters, but you had some disadvantages going on with just basically bad DSP design. And then it went into the DA converter, where sometimes the same thing happened all over again. And the problem is you might already have an ADDA chain going on in your processor too. So you've got, multiple conversion points. And a lot of people didn't like the idea, or still, I think, don't like the idea of converting from analog to analog to digital over and over again, because they're assuming, and in the past it was rightfully so, that it's introducing a lot of bad errors and making the sound bad. But today, through these commoditized parts, we have the ability to produce amplifiers that have built-in converters like this that are basically perfect. They can be technically really excellent, and they don't introduce a lot of the errors that used to be common. On top of that, it is possible to create certain types of digital amplifiers that can accept a digital signal directly. You can, for instance, convert a pulse code modulation signal, PCM, to a pulse width modulation signal, which is what one of the forms of digital amplifiers could potentially use. And NAD and a few other companies have gotten big on that, but you can do that in these closed loop systems as well, which eliminates one of the conversion stages. So the point of all this is that you now have amplifier chips, and they have all the ADDA converters and the DSP processor built into the chip. And these chips are tiny. I mean, I've seen some of these where you've got a chip that's about the size of a quarter, puts out 25 watts times 2. I mean, an honest to goodness 25 watts times 2, and it's got 30 biquads, 15 per channel. So you could throw that easily into a little tiny bookshelf speaker, and it would actually be a pretty decent bookshelf speaker you could make out of that with that much DSP power. And that's enough amplifier power for a small, especially like a lifestyle type speaker, or even for a lot of people, probably be fine, instead of a sound bar. But they also make chips that are the size of, $1, let's say. So we're still not talking something very big. Maybe
we're also not factoring in the heatsink. You still need to put a heatsink on these things. You're not just
but the heatsinks anymore is like the aluminum backplate. There's just not much to it. So, but the point is, they're very small. You've got bigger ones though. They might produce 100 watts times 2 or 100 watts times 4, sometimes even. They've got 15 to 20 biquads per amplifier channel, and you can just throw one of these into a relatively small enclosure inside of these speakers and make a pretty good speaker for not a lot of money. And those chips themselves cost $5-6 to a minute.
Yeah, TI is heavily invested in Class D amplification, portable Class D amplification. I think they're using a lot of active speakers, whether it's the portable ones that you hold in your hand or like bookshelf speakers, like you're saying. One point I wanted to bring up about all these analog to digital conversion stages, I think that's kind of like an old concern, because in most cases now we're doing everything with digital sources, with the exception of maybe a turntable. Everything you're doing now with these active speakers, you're streaming from Tidal or whatever. That's done through coax or through Toslink, or if you're doing even SACD, you can get a really high-end SACD player. And I'm not sure if any of these active speakers will take HDMI in that'll allow you to do it through the digital domain. I haven't really seen that. But I guess that's like maybe the only case where you're putting an analog SACD signal output into one of these active speakers. But like you said, the A to D converters, like I recently reviewed an Anthem STR preamplifier, And I was pretty blown away by how transparent the analog to digital converters were on that. I could not really measure any problems with it on my audio precision. It maybe added a couple of dB noise as opposed to just the digital signal, but we're talking down in the mud. We're talking down below 100 dB, which is imperceptible from your hearing. Even though you can measure it on a piece of equipment like that, you can't hear that kind of sensitivity. So, like I said, I do believe that the majority of the sources people are streaming and listening to today are digital. So, and the analog converters are so good, like you said.
Yeah, they can be. I mean, I know you've even recently measured products, especially receivers that have poor quality analog to digital filters. But I think in many cases it's because that's an afterthought part.
That's a tragedy, actually. That I was thinking about that. Yeah, I'm looking at our processor right now, and they even admitted to the fact that the A to D conversion is not a priority. So they used a high grade D to A, but then they used a mid grade A to D, and that did add a good 10 or 15 dB of noise. And when I do the review on this product, I will basically be telling people, if you're going to use vinyl, get a separate phono preamp and use the pure direct mode on the receiver, and don't use their analog section.
Yeah, and while I think that's in some ways worse than usual situation, I do think the analog to digital chips that are used in a lot of mid-grade to even like kind of lower upper end, like slightly above mid-grade, are pretty poor quality. And I guess my point was that I would not assume that that's true of a speaker, because those speakers, it's understood that the AD filter has to be good. The AD chip has to be good. So in those products, that problem, if you will, is already built into the system. They already understood the parameters of the AD chip and designed around it. And they chose an AD chip that's performance was good enough to not compromise the speaker. In receivers, like you said, basically the only thing you've got left that's analog is going to be cassette tapes, if people are still in. Apparently those are getting big again.
Oh, no.
Yeah, and record albums. And because a lot of, I mean, as much as they've had a bit of a revival, they're still not very popular. And so these manufacturers are not prioritizing them. But again, it's a different scenario than what we're talking about in terms of what's built into these active speakers.
Yeah. Well, I think we hit all the topics. I was kind of looking through the comments here, and there's just a lot of discussion, pretty technical discussion about different kind of design approaches and stuff. Nothing that really stands out for me to repeat, unless you see any comments you want to address here. Someone's saying they want to see me do more Atmos videos. Please. I thought I covered that topic to death. I will tell you this much: when Dolby tried to do the head-related transfer function response in the analog domain with an 8 or 9 element crossover, I just scratched my head and laughed, because they're trying to hit very high Q responses to do noise shaping with, as we talked about before, the parts tolerances alone would make that very impractical. And especially with the driver, you don't know what kind of driver is being used. That also changes as tolerances there. All of that type of shaping should be done in the digital domain. It should never really be done in a passive crossover. So that's what I'll say about Dolby Atmos. And we're talking about the up-firing speakers, which we're not huge fans of to begin with.
Yeah, it was a compromise, and I think you and I think we might actually maybe do a future video on this, just because we have a friend who's very interested in participating in this. But I think that probably was a choice that was made solely as a way to sell this. So they understood going into it that they were designing a complex surround system, and that it would not have good buy-in if they said to everybody, well, we need you to drill 4 holes in your ceiling and install 4 more speakers. You know, that was going to be a huge turnoff to a lot of people. And even though that is the right thing to do, and it will give you the best, most immersive experience, they came up with a compromise. The problem is they sold it as if it was the equal of drilling 4 holes in your ceiling and putting discrete speakers there. And
or better. I mean, the white papers that were regurgitating on other websites like AVS Forum, they were basically saying this is the better solution, is to put the up-firing speakers. And the other reason why I think they were pushing that so hard was because they wanted to basically become a speaker company. They wanted to sell the rights of a crossover design and a driver type, and then have companies pay a licensing fee when they put the word Atmos on their speaker modules. And I think that kind of blew up in Dolby's face because it just looked ridiculous. They're not a speaker company, they're a technology company.
Yeah. And I'll say, you know, yes, we're reviewers, but we are also consumers. In many cases, we are reviewing for the purposes of helping consumers make decisions. I found that whole thing very confusing. I remember looking at some of the speakers and saying, I don't know the difference at this point anymore between the, let's say, Triad up-firing Atmos speaker and the Onkyo. You know, I'm guessing Triad is using better quality drivers made by FIFA, and I would hope it sounds better, but supposedly they're all using a Dolby design and filter so that they have exactly the same response and performance, which can't be true. But
They were
that's how it's being
radically
sold.
different. You had the Triad had 4 full range drivers in it, and then Clip started doing them with horn directivity control. So it's like, how could those be similarly good when they're completely different design parameters and designs?
Yeah, we've gone way off track at this point, but you can tell that this heats us up because I don't think you or I really liked that whole period in the home theater world. It steered us in the wrong direction.
Yep. Well, I think we're done with that topic. I think we've covered active versus passive. This certainly won't be our last video on the topic. In fact, I'll probably have some guests in the future. I know RBH Sound is working on an active tower, which I can't really talk too much about now, but it's very exciting. I mean, I was kind of like sitting back, always thinking active speakers were limited to just bookshelves or portable speakers. But, aside from the fact that Meridian's been doing this for a very long time at the very upper end of the market, but now we're starting to see more of this happening. More of the brands are starting to adapt it. So I think it's an exciting time to be covering them.
Yeah, I'm actually really excited to see that speaker, and I suspect that this is probably the first of things to come. But I won't divulge anything I've heard either. But I will say that when I first heard about it, I was like, all right, we'll see what this is going to be. And then when details of what it was going to be started to come out, I thought, oh, this is actually really cool. So I can't wait to see your impressions of it, to start seeing pictures of it, and to be able to start talking with everybody about the technical capabilities of that system.
Awesome. Well, guys, I think this wraps it up for our Friday evening. I hope you enjoyed this discussion. Don't forget that we do have a Patreon channel. It's patreon.com/audioholics. If you subscribe, you get some of our videos and some of our content before everybody else. You could also recommend what other topics you'd like us to cover in the future. If you like this video, thumb it up. Make sure you hit the notification down below so you know when we're going to go live again and when we're going to do a new video. And my friends, until next time, keep listening.